numbers yet?
No, we won't till we actually start it.
Okay.
Okay, it looks like we're live on YouTube.
Yep.
Okay. Okay, here's where I mute my mic.
Testing. Okay. We all set then? Good. Good evening, everyone, and welcome to this evening's webinar on tidal swamps, secret forests of the Oregon coast. My name is Ben Pittenger, and I am the Executive Director of the Lower Nehalem Community Trust, one of the co-sponsors of this evening's presentation. Before we start the presentation, I'd like to welcome our attendees on Zoom and YouTube live stream and take a few moments to orient you to each of the platforms. For our Zoom attendees, if you're familiar with Zoom, you may have already noticed some differences. For tonight's presentation, you do not have a camera or microphone to worry about. We do want to give you a chance to ask questions of our guest speaker. We will be using the Q&A function exclusively to do this tonight. You can find this on computers by hovering over the bottom of the screen or by pulling down from the top on handheld devices. For YouTube, you can ask your questions through the chat function, which should be to the right of your live stream's video player. Please submit your questions as soon as you think of them. There's no need to wait until the Q&A segment of the presentation. A team is standing by to review all of the questions as they come in. They will consolidate them and address them to our speaker. We'll acknowledge your question and try to answer as many as possible in the time allotted. Well, enough of the logistics. I'll start this evening's program with a brief introduction of Lower Nehalem Community Trust. LNCT is a land trust, and that means our work is dedicated to the conservation and restoration of natural lands for the protection of the plants, animals, and ecosystems native to our region. We also do education and outreach to our community and get our community involved in our activities, and that's what you're seeing tonight. We operate in the Lower Nehalem River watershed, here by the northern edge of the Tillamook County coast. The lands we protect include wetlands, streams, meadows, and forest lands around Nehalem Bay, as well as forested lands higher in the watershed. We are community supported. If you are curious about what you hear tonight and would like to get involved or learn more about what we do, please visit our website where we describe the lands we protect and the work we do. If you like what you see, you might even click on the donate button to support our work and encourage us to do more educational events like this webinar. Also, please mark your calendars for March 29th. That's when we will have our next webinar. I'm kind of excited about it. It has to do with research that was done on Botts Marsh, one of our properties. And the authors of that study will be talking about the historical earthquakes over the last 2,000 years in our region. Our co-sponsor for this evening is the Nestucca, Neskowin, and Sand Lake Watersheds Council, way down south at the other end of Tillamook County. Joining us on this webinar is Caleb Menser. He is the Outreach and Project Development Manager with the Watersheds Council. And since I don't know Caleb very well, I'm going to hand this off for him to introduce himself and the Watersheds Council. Welcome, Caleb.
Well, thank you for that quick intro, Ben. As you mentioned, I am Caleb Menser, the Outreach and Project Development Manager for the Nestucca, Neskowin, and Sand Lake Watershed Councils. Our geographic area is from Cascade Head in the south to to the north end of Sand Lake. So we have Neskowin, the Nestucca, and Sand Lake, as the name implies. This is a big geographical area with many, many restoration needs. A few of our current really spotlights are fish passage projects, which we do a lot of culvert replacements with bridges. We also do a lot of riparian planting, as well as some tide gate work and estuary work. So we really wanted to get Laura to come speak with us. It was actually a year ago that we were trying to plan you last time I saw, and then we got shut down. So it's great that we made it happen. So some other types of events we do, outreach types events are invasive removals, bay cleanups, and like kayaking the bay and guided hikes like that. So hopefully we can get to do more of that here in this next near future as well. But other than that, a big thank you to everyone up at Lower Nehalem, the behind the scenes hosts, as well as Ben, and also Laura from the Institute for Applied Ecology. So thank you so much for being here. And I'm going to send it back to Ben, and he's going to introduce Laura.
All right, now to the main event. Our speaker, Laura Brophy, is the director of the Estuary Technical Group at the Institute for Applied Ecology, a nonprofit in Corvallis, Oregon. She says that her goal and the work that excites her is to provide solid science to support estuary restoration and conservation. She has led on-the-ground monitoring of Oregon's largest tidal wetland restoration projects, and the results have led to some big advances in estuarine ecology and restoration science, which she has applied in collaborative projects across the US West Coast and nationwide. Laura's work also focuses on raising awareness and improving our understanding of Sitka spruce forested tidal swamps in the Pacific Northwest, their ecology, their history, and their current status. When she's not studying tidal wetlands, Laura plays the fiddle, mostly American old time and Irish, and she and her husband Kevin have a band called The Nettles that has played for contra dances across the Pacific Northwest for 25 years. Okay, now we start with Laura.
Thank you so much. I will get things rolling here. What a nice introduction. Thank you, Ben. So this is probably my favorite topic in the world, so thank you all for coming to listen tonight as I tell you about tidal swamps, the secret forests of the Oregon coast. Let's see if we can get a slide advance. There we go. So you already heard about the the Land Trust and the Council that are sponsoring my talk, and my organization is the Institute for Applied Ecology. These are all doing great work. Thanks to everyone involved. And the information that I'll present comes from a lot of different projects, which had a lot of different funders and a lot of different collaborating people and organizations. So, and this isn't all of them on this slide, but I'm very grateful to all of them. So I have sort of a group of messages I hope to send home with you this evening. And it starts with what is a tidal swamp, and then a little about what they do for us and for fish and wildlife, and then some of the interesting facts that we've learned about tidal swamps, including how have they changed through the years, going back actually a couple of centuries. And finally, I want to leave you with some thoughts on what we can do to restore tidal swamps, because as you'll learn, we need to restore them, if you didn't already know that. So tidal swamps are one type of tidal wetland. That's probably pretty obvious. And as you probably also know, all tidal wetlands are found in estuaries, like the Nestucca shown in this picture. And this is where estuaries are, where the ocean meets the river. And so you can see marshes here and some ag lands that are diked off. You can see the bay and the sand spit. This is pretty typical Oregon estuary, the Nestucca. Tidal wetlands, like all wetlands, are defined by their hydrology, how water moves through the system, by their soils, and by their vegetation. And tidal wetland hydrology is what makes them really interesting to me. The wetland surface is inundated during high tides. The water that inundates the wetland surface might be really salty, it might be brackish, or it might be fresh. And I'm talking about tidal wetlands in general here, not tidal swamps in particular. Tidal wetlands also often have freshwater inputs in the form of streams flowing into the wetland, but every tidal wetland in Oregon has a lot of precipitation input, so we always have freshwater mixing in with salt water if there is salt water present. The soils in tidal wetlands, like all wetlands, they're saturated a certain amount of the time, rather a lot of the time, and in tidal wetlands, often the soils themselves are salty too, because they're soaked with salty water. But not all tidal wetlands are salty. Some are fresh, and they just receive tidal inundation with the backup of the river flows by the high tides. So almost all tidal wetland soils tend to have rather a lot of organic matter in them too, and that's become something of strong interest to people with all the interest in carbon sequestration and mitigation of climate change. Soil textures in tidal wetlands in Oregon usually tend to be pretty fine textured, like clays and silts, not the sandy soils that are found in beach type environments. Our estuaries are more protected, so the soils are usually finer textured. So back to the topic of what's a swamp versus other kinds of tidal wetlands. So some of the the two major types of vegetation that I'll be talking about are marsh and swamp. And tidal marsh is what people also call it salt marsh, and it's the most recognizable type of tidal wetland. So when you drive along Highway 101 and you're looking out across the edges of the river, you'll see tidal marsh quite often. But then there are these other, and I should mention there's low marsh that's pictured here, and then high marsh. They're quite distinctive. And then there's the two types of tidal swamp, the shrub tidal swamp here, and then the forested tidal swamps. And I'll be talking today about the forested tidal swamps. So the term swamp just means woody plants like shrubs and trees dominate the vegetation, whereas marsh doesn't have woody plants. It has low-growing grasses and other low-growing non-woody plants. So here's a few more pictures. Low marsh and high marsh, that's the Nehalem on the upper left there. This is some tidal marsh again in the Nehalem, just west of Nehalem Point. That's Alder Creek flowing in at the top there. So I'm sure many of you are familiar with this beautiful tidal marsh. And tidal swamp, both of these are taken in the Nehalem estuary at Coquille Creek Swamp. That's on the left there, you can see Katie Volke from the North Coast Land Conservancy in the foreground, and my daughter, this was probably 15 years ago, in the background, in a willow swamp at the edge of Coquille Creek near the road. And then on the right, you can see one of the smaller tidal channels in the Coquille Creek Swamp in the forested section where there's big Sitka spruce. So these different types of swamps, the shrub and the forested, and marshes too, are found in the landscape in patterns that reflect conditions, physical conditions. And this is an example from the Columbia, and you can see this is one of the least disturbed areas of tidal swamp in Oregon. And you can see these lower areas, which are willow mostly, and then these higher looking, rougher vegetation, that's Sitka spruce. So the patterns are really interesting and fun to learn about. And those patterns and how the different habitats are distributed across the landscape is shown in this diagram from 1999 that actually was originally Bob Bailey developed it for the estuary plan book, and Jim Good adapted it for another document. And it shows how things are organized out there in the estuary. You have the ocean, you have a sand spit, and then the mouth of the river. Then you'll have mud flats, tide flats, tidal marsh on the edges here, and then they showed a little bit of tidal swamp here at the base of a hill slope. And what we've learned in the 20 years since then is that there's a lot more tidal swamp than that going upstream. And in some cases, there's not much more now, but there used to be a lot more in the past. So speaking of what we call tidal swamp, you'll hear different names for it because we're still so early in the process of studying it that we haven't really systematized our terminology yet. So you might hear people talk about tidal forest or tidal forested wetland or forested riverine tidal. Those are all the same. They're all forested tidal swamps. So when we get into sort of the things that these habitats do for us and for fish and wildlife, these are some of the ecosystem services or functions that they perform. And I don't need to really go into detail because probably a lot of you already know that wetlands do a lot for us, supporting fish and wildlife, storing carbon, keeping it out of the atmosphere, reducing floods and improving our water quality, etc. This list is from Paul Adams's functional assessment method for Oregon tidal wetlands. And forested tidal wetlands have some really specific characteristics that are very interesting. And since they're the focus today, I'll go into this a little more. So young salmon like to have deep and complicated tidal channels to hide out in. Well, they don't have to be deep, but having complexity in the form of large woody debris is important for them for sheltering and also to provide food for the salmon in the form of insects that live in those complex environments. And forested tidal wetlands have those. They have deep, complex tidal channels. Also, those channels filled with wood provide shelter from predators of all kinds, be they birds or other fish. And the large amount of wood in the channels in these tidal swamps also means that often the water doesn't drain out at low tide. So there's low tide refuge within the swamps, and the fish have a place to hide out during low tide, and they're not flushed out into the river, which is really good for a small salmon. And beaver are a big factor in these swamps too. They certainly are very active. And I should mention salt adjustment too, because the swamps form in that gradient from brackish to fresh. They provide a lot of opportunities for young salmon to move back and forth across the landscape and across within a given site to get to fresher water or to saltier water, giving them a chance to adjust to salt before they hit the ocean, and that really helps their survival. Now, tidal swamps do a lot of other things for us, but we're really in the early stages of learning what some of those things are. We haven't really measured these functions as much as and we have hardly started to measure their fish functions also. But in any case, we know that they have a very complicated multi-layered vegetation, which supports a lot of different kinds of wildlife. They produce a lot of plant biomass, which feeds into the food web. And I'll be telling you about soil carbon in a little bit. Other functions are no doubt present, but data are sparse and we're just learning. So given that there are a whole bunch of functions that are very interesting to people, what folks want to know, including me, is where should we act to protect and restore these functions? What exactly are we working to restore and how can we do it? So these questions have been addressed to a pretty good extent with tidal marsh, but not so with tidal swamp. Again, I'm probably repeating myself here, we're in the early stages of understanding. But we do know a few things. So what makes a tidal swamp work? What drives the system? What are the controlling factors? We're studying, and we've learned a little about the physical conditions, and the biology that results from them, and then the feedback loops that occur between the physical conditions and the biology. And we're learning what's really distinctive about these systems compared to tidal marsh, besides the fact that they have trees. And then we're also learning a lot about where these occur in the landscape, which of course is the result of those physical conditions that I mentioned. Where were they historically, where are they now, and where can they be restored, and how? So before getting into some of those interesting details about what these swamps are like, I want to just show you some photos because I find these habitat types to be very beautiful. This is one of the bigger spruce at the Coal Creek Swamp in the Nehalem. That's up on the North Fork. Here we have a tidal swamp in the Siuslaw River estuary. These are all dominated by Sitka spruce with some other tree species present. And this is back at Coal Creek Swamp again, one of the best studied swamps in Oregon now. This was taken up in the Columbia. Here we are down in the Siuslaw again. The Yaquina. A couple more pictures from the Yaquina here showing a little more close-up of the channels. So there are parts of the world where the tides go up and down just a foot or two along the Gulf Coast. Florida, there are some micro-tidal areas, but that's not what our Oregon coast is like. We have tide cycles that rise and fall 6 or 8 feet, as you know, and 10 or 12 feet on the larger tide cycles all year round. And during the new moon and the full moon, what we call the spring tide cycles, the channel that you see in this picture, which is more than 7 feet deep, will fill up to the top and then spill out into the forest. And one of the most amazing experiences that I've ever had was I was working out alone in this tidal swamp. This is Coal Creek. And it was in the summer, I think in July, and I ended up working pretty late, and it got dark. And the tide was coming up, and I had a few things to finish up. I had my headlamp, so I was still wandering around, and the water did come up over the top of the bank and started flowing through the forest. And just to be standing there on the floor of this spruce forest and watch as the water came creeping in, and then to be in like a foot of flowing water moving through the forest silently was quite an experience. And it really brought home to me what are the forces that make these swamps the way they are. So I don't really recommend doing that because it's quite hard to navigate through these swamps or even a tidal marsh at night especially, and at high tide especially. So don't do as I did, but it was a good experience for me to have. Not all of our Pacific Northwest tidal swamps are dominated by Sitka spruce. It's really, as you know, it's mostly found near the coast. So there are forested tidal swamps elsewhere up the Columbia where it's fresher, and they can be dominated by black cottonwood or by Oregon ash. Those are the dominant species, and alder is also a common dominant. I don't have a picture of that. So getting into some of the interesting details about what we've learned about tidal swamps, there was a sort of accepted wisdom in the 70s and 80s based on knowledge that people had at that time. And the understanding was that there's an elevation gradient. You go from low marsh to high marsh and then up to the swamp, and it's the highest. And there was also an understanding that you wouldn't find tidal swamps if it was at all brackish. They are only found in the freshwater tidal zone. That's that part of the estuary where the ocean water causes the river water to back up, and it rises and falls with the tide, but it's not salty. So that was what was understood at that time, and that was, you would find a number of publications that said so. But actually, that was not based on data, at least very little data from any tidal swamps at all, and none that I know of, no quantitative monitoring of salinity, and very little elevation data from tidal swamps on the outer coast that I've done most of my work on. So we want to answer those questions, and we've started answering them. In 2007, we had a project. This was the one where we first started studying that Coal Creek swamp in the Nehalem. And our project, we called it Beginning to Build a Blueprint for Restoration, measuring those physical and biological characteristics that distinguish marsh from swamp, and high marsh from low marsh, and shrub swamp from forested swamp. And we measured water levels, both in the channels and then in groundwater, shallow groundwater. We took soil samples, we measured organic carbon content and soil textures and soil salinity. And then we looked at how all those physical conditions affect the biology. So we measured vegetation and collected macroinvertebrates, and it was a very interesting study. And one of the most important things we learned was that salinity in these spruce tidal swamps can be very brackish, not just slightly brackish, but really well into the mesohaline. So that's a category that refers to middle salinity. And 15 parts per thousand is about half seawater salinity, so it's pretty brackish. So our understanding now is that when you have fresh salinities, you will probably have swamp. When you have brackish salinities, you may also have swamp. When you have strongly brackish salinities, you're probably going to have marsh, and then when you get into the near marine salinities, that's going to be a very salty marsh. So I have to say, though, that even having begun to understand that, it's much more complicated than that because of beaver. And beaver create their dams not just in our freshwater streams and our non-tidal areas, but also in brackish tidal wetlands. So these are pictures that I've taken in various brackish marsh across the coast of Oregon. And they also build their dams in our forested tidal wetlands, including, this is back, you've seen this picture several times now, that's a low beaver dam there in the one of the main channels that goes into the southeast part of Coal Creek Swamp. Here's another beaver dam in a swampy area in the Salmon River estuary. That's on Fraser Creek. So what are the effects of all those beaver dams in these tidal wetlands? As you can imagine, they affect almost everything because they hold water back, you get fresher water, they trap sediment behind the dam, they change the inundation patterns. Fish will use the beaver dammed areas, and they provide great fish food and great growth opportunities for fish. They cause a lot of carbon to be stored behind the dams too because of all the sediment being stored there. So that's because of all those effects on the physical environment. Beaver are called ecosystem engineers, and those beaver activities and their effects on stream systems have been studied considerably, as you know. Beaver are very important keystone species, they call them. But one of the interesting things too is that Sitka spruce are also ecosystem engineers. They actually do change their environment. They grow on very wet soil, and then they build a root platform which elevates some of their fine roots and gives other plants and animals a chance to be above the very wet soil. So that you're seeing a root platform here at the base of a spruce tree. Here's another picture that these platforms are formed where there's sort of a buttressing that occurs at the base of the tree, and then the roots extend out horizontally. And in this picture, this is at the edge of a pasture, so the ground has been trampled up a little by the cattle, and you can see the platform better. You can see a lot more how it's elevated. It's probably a couple feet above the wetland surface here. And the platforms, the root platforms themselves are fairly thin discs for the size of the trees, so spruce tend to topple over during windstorms. And this happened at Coal Creek in 2007 when we had that big December gale, which I'm sure many of you remember. And this big spruce went down. That's me looking at the upturned root disc, really. You can't call it a root ball, it's flat. And here's 4 of us standing next to it, so it's an impressive platform that these trees build. And like beaver dams, that affects everything, so it creates a very different physical environment, elevated above the inundation, except occasionally, much less salty, less saturated, and all of those things make a difference in how carbon is stored as well. So besides the root platforms, tidal swamps also tend to have a lot of hummocky ground formed by fallen trees. If you've ever walked around in one, you'll know it's almost impossible to walk around in them. The vegetation is very multi-layered and dense. It creates really good habitat for a lot of different kinds of wildlife. So in a tidal marsh, you might see marsh wrens and sparrows and shorebirds, wading birds, waterfowl. But in the tidal swamps, you'll see pretty much the full range of birds that you'd see in any forest. So raptors and owls, woodpeckers, finches, thrushes and flycatchers, and quite a diversity of birds. This multi-layered appearance of the vegetation it's pretty striking. And I mentioned large woods, so trees fall down, they fall into the channel and elsewhere, and when they fall in the channel, they often stay there because there's not a lot of water velocities in these channels. So the fallen wood will be present in the channels for a long, long time, making good salmon habitat. There's another picture of large wood in channels. It's kind of hard to get pictures because it's often quite dark in these swamps. But you can imagine it's providing very good shelter for juvenile salmon. And because of the pools that are formed between spruce roots and between large woody pieces, you get this low water refuge, low tide refuge that I mentioned earlier. Young salmon are not swept out into the river before they're ready, and that's very good for them. So where do these tidal swamps occur? I've been talking about what they're like, but where are they on the landscape? And we have finally, in the last couple of years, really been able to map their locations, both current and past. It wasn't easy before we had certain kinds of data, specifically elevation data, because you would look out at the landscape and you would see, clearly this is a tidal marsh. That's pretty obvious. We're in an estuary. We're near the ocean in this picture. But is this forested area a tidal swamp? You just can't tell by looking, and even if you walk out there, it isn't always easy to tell. So we needed to know what the elevations of the wetland surface were in these tidal swamps, and it's very difficult to do line of sight surveying, which was the old way of getting elevations. So it became really important to have GPS. And in 2007, we had fantastic help from the National Geodetic Survey folks. This is Doug Adams. And they came out and helped us measure elevations in these swamps. Really gave us a big jump forward. It was hard because in the dense swamps, it's really hard to get a GPS signal, but they had some very tall antennas like this one, 20-foot tall antenna. So they were picking up a signal for the GPS unit with that. And then shortly after we started getting good GPS data on elevations, we started getting LIDAR data too. And LIDAR, if you're not familiar with it, it's a form of radar flown in an airplane, in our case, and they shoot the radar beam at the ground and it pops back up and they measure how far away the ground was. And it's miraculously accurate. It's usually accurate to within just less than 6 inches of elevation. So we can create these elevation maps like this one, showing high ground in red and low ground in green and blue. And I'll just zoom in on part of this picture, which is, it's in the Siletz estuary, near Highway 101 actually. And the level of detail that you can see here showing channels and so forth is just amazing. So it was a giant leap forward for us in understanding our estuaries. We now really could see what areas would inundate. And the availability of LIDAR then led to this project that Andy Lanier headed up. So at the Oregon Coastal Management Program, I worked co-leading on this project with the technical methods development. And the goal was to update the resources that underlie the comprehensive plans used on the Oregon coast. So updating Oregon's estuarine wetland habitat maps. And our plan, our goal is to map the full historical extent of each estuary. And that goes from ocean to head of tide, and it includes all of the tidal wetlands, not just salty ones, including the whole freshwater tidal zone. And what was different and only possible because of elevation was we also mapped former tidal wetlands that are now diked. And that's important for understanding impacts to our estuaries and for planning restoration activities. So the key mapping questions when you're using an elevation-based mapping method like this are, what's the downslope boundary on the ocean side and what's the upslope boundary? And the downslope boundary for vegetated tidal wetlands, you can see it in an aerial photo, so that's not too difficult. But the upslope boundary was more problematic, and it required a definition that's clear and repeatable, and the definition that we use is annual high tide. And that's a definition that's really used around the country quite widely to define the limits of the estuary and of tidal wetlands. So that's our elevational boundary that we use for mapping the estuary, and I'm going to show you an example in the Tillamook of how it works. So here is Tillamook Bay, and this big floodplain where the Tillamook River, the Trask, the Wilson, and then the Kilchis comes in here, and then the Miami up at the north. So it's an interesting system with a lot of complexity. And I'm going to take you down to that red circle at the bottom. This is down in the southern part of the estuary, so I'm focusing in on just these agricultural lands here. So when you just look at this aerial photo, it isn't easy or even possible to say where were tidal wetlands way back in the day before everything was turned into productive agricultural fields. That question can really only be answered with topography data, really good elevation information, and the LIDAR gives us that. So this, what we call a LIDAR elevation map, is shown in color here, with red being higher and green and blue being lower. And when we draw that annual high tide line as a black line here, that shows us the historical estuary boundary, because sea level has not changed much yet. So we can use current data to determine past extent of the estuary. So it's really handy having this black line, because it allows us to ask questions about what was there historically, what's there now, and also that line can be moved upslope if we're considering sea level rise. So we do look at historical conditions using maps like the ones that are provided at Oregon State University here, maps from the 1800s. And then for current conditions, I'm repeating this slide because we go to this OCMP study and the products from this study, which included current vegetation within the estuary. And we overlay all these things to get at the change that's occurred in the estuary. So there's that black line for the historical extent. And within that black line, we look at what areas are disconnected now, what areas are diked. And that came from that OCMP study also. What areas were forested versus, marsh back in the historical times, and what's the vegetation like now inside that line. And by analyzing those things together, we can determine two different main kinds of loss. One is loss due to diking or tidal disconnection, which takes this wetland out of the realm of being a tidal wetland. It may still be a wetland or it may not. And then we have vegetation change as well. So we have losses due to, say, the removal of trees in this case. So some of what we learned through that mapping work was quite eye-opening, I think. Historically, over half of the Oregon coast's tidal wetlands were forested. And we have found from other researchers that was true throughout the Pacific Northwest. So a majority of our tidal wetlands were forested tidal swamps back before there was much settlement by Europeans. Close to 60% was either shrub or forested tidal swamp. And what this tells us is that we really need to broaden our focus when we're doing restoration projects and thinking about what we need to bring back into our coastal landscapes. We need to think about tidal swamps as well as tidal marsh. We learned by that analysis I just showed you that we lost almost all of our tidal swamps. We already had a pretty good idea that that was going to be the outcome, but we didn't have an exact number until just recently. So the loss of historical tidal swamp has been over 95%. The loss of the historical tidal marsh was about 60%, and we've gained some of that back. And I'll talk a little more about that in a minute. So that's a pretty distinct difference. And I want to show you some pictures of what that looked like for the estuaries that you're involved with if you're from the Nehalem, Nestucca, Nestucca, Sand Lake area. This map shows in blue, let me make this bigger on my end here so I can read my own legend a little better. So what you'll see here is blue, dark blue represents areas that were historically forested tidal swamp. That's this color here. And then the lighter blue is areas that were historically shrub tidal wetlands. And then the remaining current tidal shrub and forest is shown in these orange and red colors. So you can see that the tidal forest was quite a lot more extensive historically than it is now in the Nehalem. 61% of the tidal wetlands in the Nehalem were forested historically, but 87% of those tidal forests have been lost. So that's a big change. For the Nestucca, 53%, not quite as much of it was forested. And I should have pointed out this light gray, or the darker gray color, represents areas that were historically tidal marsh. And then the light gray is the open water. So in the Nestucca, you can see all these blue areas that were historically tidal swamp, but they are no longer tidal swamp today. 99% of those have been lost. So there's really not much left in the Nestucca of tidal swamp. It's more extreme in the Coquille, where 84% of historical tidal wetlands were forested and 99.8% have been lost. So this is not an unusual change on the Oregon coast. Generally, these tidal forests were logged off and altered very early. One other really interesting thing that we were finally able to quantify across the entire coast was the total gain of new marsh. So we haven't gained any new forested tidal wetlands to speak of, but we have gained rather a lot of new tidal marsh since the 1800s. These are areas that were mud flats back in the 1800s, but there's been a lot of sediment moving down through the system, and due to the presence of dikes, quite a bit of that sediment has made its way out into the bays and has formed new marsh. And that's why we've seen a 1,770 hectare increase or an area of new marsh. We've lost lots of marsh too. So it's balanced out in part by the gain of new marsh. There's been very little erosion or drowning of marsh on our coast to date. That's really different from some other parts of the country. You've probably heard about the drowning of tidal wetlands on the Gulf Coast due to sea level rise and changes in sediment deposition rates. We have not had that problem in Oregon yet. So we're lucky so far. And the gain of new marsh and the availability of sediment for formation of marsh and for restoration of marsh suggests that our tidal wetlands on the Oregon coast may be better, may have higher level of resilience to sea level rise than some other parts of the country. But we're still concerned. And I want to show you some new marsh in these estuaries that we're talking mostly about today. So this dark blue color here in this map, this is a different color scheme than the last map I showed. The dark blue here shows new areas of marsh that were not present in the 1800s but are present now. And in this map, red means diked areas. So this is the Nehalem. And that you all who live and work in the Nehalem know that the marshes have expanded in the Nehalem into the bay. And that's been documented and written about by people for a couple decades. In the Nestucca, there's been some new marsh too. It's mainly sort of more internal to some of these areas that were mud flat back then, but have filled in with vegetation now. And at Sand Lake, there's been a similar kind of infilling of some areas that were mud flat in the 1800s, but are now tidal marsh. Tillamook is an area that has seen quite a lot of new marsh formation. These are marshes along the east side of the bay, at the mouths of the Wilson and the Kilchis rivers. So, inquiring minds want to know what happened to all the tidal swamps. A lot of them now are behind dikes and have been converted to pastures. So this is an area in the Siuslaw River estuary illustrating that. You can see dikes along this. This is the North Fork of the Siuslaw. You can see some dots here where the rancher has been maintaining the ditches and piling the material at the side. And you can also see in this picture some non-diked tidal marsh here. This is called Bull Island. And then you can see an area where the dike breached in a storm and it became a restoration site at that point. The landowner decided it was time to let it just become a tidal wetland again. This is a pretty typical looking diked former tidal swamp. This is down in the Umpqua. And many of the areas that were formerly tidal swamp were logged for spruce production. Actually, during World War I was a big time for removal of spruce, and these areas then could become agriculturally productive. So it was a dual-purpose effort. And the spruce that were growing near the rivers were the easiest to cut and the easiest to transport. So these tidal swamps, I expect, were changed very, very early. And those losses, those changes, are have a high impact on all the different functions that we care about, these functions that I mentioned before. And I want to tell you a little bit about carbon storage because it's a sort of a hot topic right now. So tidal swamps, the forested tidal wetlands, really store a lot of carbon. So this was a project that Boone Kaufman led and I was involved with along with rather a lot of other people looking at carbon stocks. That means carbon inventory, literally like what you'd have in a store. This is your carbon inventory held in the soil and in the plants of different types of tidal wetlands. And I'm pointing here to the tidal forest of the Pacific Northwest. This is from our study. And you can see it's the highest bar. It has the highest amount of carbon stored per hectare, more than any other global average for mangrove or for seagrass or for tidal marshes in Brazil. It's a high number. And if you're interested in the local tidal swamp and how it does, it's among the highest of the highest. So Coal Creek is the second to left bar here. I guess there are other tidal swamps in the Northwest that were higher than Coal Creek, but there's a lot of carbon stored at Coal Creek based on this study, and it was a good intensive study. So in terms of salmon habitat, when you block off the tides, you're changing the system tremendously and altering many of these characteristics that are used by salmon. You can have systems with fish-friendly tide gates, which do allow fish access and allow some of these fish functions to return, but you don't have the full suite of functions by any means, and it's a very different system. And Greg Hood pointed out, and I think it's a very important observation, that salmon don't just live in tidal channels, they live in tidal marsh. The surface of the marsh itself is fish habitat. They actually use it and feed in it during high tides. And we like to expand that a little and point out salmon don't just live in tidal channels, they live in tidal wetlands in general. So forested and shrub tidal wetlands are fish habitat too. So Corey Green and his group, working up in Puget Sound, they were looking at how young Chinook salmon grow, their growth potential in 3 different habitat types. Actually, I think it was 4 in Puget Sound tidal deltas. This image is an aerial photo of the Nooksack River Delta in Puget Sound, and they looked at mudflat, emergent marsh or tidal marsh, and then shrub habitats here. They called them estuarine forest transition. And then they looked at the forested riverine tidal. And their conclusions, I won't show you all their data, but it's a neat paper. Let me know if you want it. They concluded that habitat diversity is really important for maximizing the growth of young Chinook. Basically what they saw was that these different habitat types have, at some time or other during the year, the marsh, the shrub, and the forested tidal wetlands all have about equally high salmon growth potential. They just vary on when that's provided. So to give salmon the most opportunities, you really want to restore all of these habitat types. So we have to think when we do our restoration projects about habitat diversity and the distribution of these habitats across the landscape, as well as just salmon production per se. So how do we restore tidal swamps? We really want to do it right, and it's not always simple. Some of the steps are very basic. The devil's always in the details. The first step is to choose an appropriate site. So that's why we need the information on the physical conditions in these tidal swamps, so we can then find a place in the landscape, be it altered, that has those same physical conditions, elevation, salinity, etc. And then once we've got the appropriate site, the design of the restoration project involves some of the same things that you do at all tidal wetland restoration projects. You bring the tidal flows back. You restore those important channels. Also woody plantings, of course, because it's a forested or shrub habitat, and because we do have some problems with reed canary grass, which is very competitive in the fresher areas. We want to plant our woody species and maintain those plantings and give them a head start. We also, when we're addressing these restoration projects, we have some challenges. and I've just touched on these a couple times in my talk. One is land use affects the soil. You'll have compaction of the soil due to land use, and you'll also have changes due to drainage and oxidation of the organic matter that's in the soil, which causes the soil surface to sink. And we call that subsidence, and it results in what used to be a tidal swamp at, say, 8 feet or 9 feet elevation. Then after it's been diked and used for agriculture for a while, it may only be at 5 feet of elevation. And that means that you might not be able to restore tidal swamp where it was present historically. So that's one of our challenges. But with time, these sites should be able to accumulate sediment and get back to their original habitat type. But sea level rise throws a wrench into that. So there's some complexities to this. Another issue really is channels. So tidal channels in a natural system, shown on the left there, are incredibly dense and intricate. And we've had the pleasure of working with data produced by some very intrepid people who walked every foot of the tidal channels in this system here. So we know exactly what the total length of tidal channels is, and we can get the density per acre. So you have 10 times the length of tidal channels in a least disturbed site like this compared to a typical ditched site. That's a big change. And those channels are really important for bringing the tides into the site. And of course, they're important for fish habitat too. Another issue I mentioned is reed canary grass. This plant is awfully competitive, especially in the lower salinity areas. So it's important to get woody plantings going to shade it out. And it takes some work to get the trees and shrubs above the reed canary grass. One of the ways that has been developed recently is Jake Robinson, who's worked on the South Coast and with several different councils, has developed this idea of log cribs, which provide an elevated surface in which you plant the young spruce trees. So these bundles of logs are tied to vertical pilings, and they can float on a high tide, lifting up the whole. It's like a raised bed. They lift up the whole raised bed. And the trees are planted inside there in a bunch of soil and mulch. And the idea is you give them enough of a chance to get their roots established, and then they will outcompete the reed canary grass. And here's a picture. I don't have a good one, but Jake took this about 4 years after that log crib was first built. And you can see the spruce look pretty healthy. They're not huge, but they're getting going. And this is from the Schofield Creek area in the Umpqua estuary, and Partnership for the Umpqua Rivers has experimented with making holes in nurse logs and then running some chainsaw slots down to the surface of the wetland so the trees have a way to get their roots down to the wetland surface. You'd have to be careful with nurse logs that you're not going to have high water events that will just roll those trees and your young ones won't make it then. Another approach that may be a little more stable for the longer term is to build some mounds. I was talking with Craig Horner today about his work at Anderson Creek at South Slough, and they build mounds made of a bunch of wood and debris thrown together with some soil and piled up, and then planted spruce and other upland plants on these mounds, and these are on a fairly low wetland surface, and it gives the woody plants a chance to get a start above reed canary grass, and then also they grow, they produce wood that drops, and they serve sort of as a nucleus for development of further higher ground. So I think that approach has a lot of potential. And then I mentioned sea level rise. So that creates a challenge for all of our work, obviously. And as we think about what elevation a tidal swamp needs to be at, we have to also be thinking about what elevation it might need to be at 20 or 40 or 60 years from now. So it's a topic of a lot of interest, and we did a study in 2017 where we mapped potential future tidal wetlands, and we're using these data quite a bit right now to find the locations that will be at the right elevations in the future. And really, one of the biggest points is just if we can maintain somewhat natural conditions across a gradient of elevations, then we give tidal wetlands a place to go as sea level rises. And if we're lucky and sea level doesn't rise very fast, then that gradient is still valuable because ecosystems like having a gradient of conditions for organisms to move around in. And those restoration methods I mentioned, like the log cribs, the nurse logs, and the soil mounds, those all may be important in our sea level rise adaptation efforts in elevating the trees that we want above rising tides. And then the characteristics of spruce trees themselves may help us, because their ability to form these root platforms and elevate above the wettest soils it's a pretty amazing thing. So they may help us. They may help themselves too. So, in summary, I hope that I've covered these topics and given you some understanding of the historical importance of tidal swamps on the Oregon coast and how many of them are gone now, and what they did for us back then and what we want them to still be able to do for us now, and therefore our work to restore these tidal swamps and to preserve and conserve the remaining ones, which are so important. So your own potential work, if you're interested in these swamps and in what these organizations do in general, is get in touch. There are volunteer opportunities, I'm sure, for all of these groups, and they do wonderful work. So I really encourage everyone getting in touch. And hopefully I'm sending you off with answers to these questions. And if you have other questions, well, first you could go read the report that's at this link, and I think that this talk can be distributed as a PDF as well as a recording to make it easy for you to click on the link. And there's also a little web app where you can explore the data interactively without having to have a fancy GIS program. So now, having just spoken of questions, I hope you have some questions for me, because I would love to answer them.
Okay. So I'm just going to introduce myself real quickly as the person behind the curtain. My name's Debbie Moberly, and I'm with the Lower Nehalem Community Trust. And I'm going to do my very best to deliver questions to Laura on behalf of our viewers. And some of these questions are kind of complex, so I'll probably just read them and let Laura sort out how to answer them. So Greta, who I happen to know is tuning in from Arizona, is curious why this is a new field of study. The tidal swamps have been here for as long as the tidal marshes, and it seems obvious that they would be an important part of estuarine riverine ecology. Why have they not been studied historically?
That's a great question. Have you, I can't interact with you, Greta, but it's part of what we call a shifting baseline problem. So people, we only, a generation is 20, 30 years. We tend to think mainly of what we've seen during our lifetime and what we talked with the previous generation about. And so when something changed 150 years ago or 100 years ago, we're not very aware of it. And we may only be aware of the changes that happened in our own lifetime. So since most of these forested tidal wetlands were logged off a couple generations ago, I think they kind of disappeared from our cultural memory, and they were so eradicated, like 95% loss, that I think they became somewhat invisible.
Okay, so we have a question from Ken. To what extent has historic salmon trapping by indigenous people acted like beaver?
That's an interesting question, Ken. The salmon traps I've seen were fairly, I would say, not as substantial in size and didn't have as much hydrologic effect as a beaver dam. The ones I've seen have been mainly weirs that were in the channel. Of course, I've seen remnants that are from probably 100 years ago. But my impression is that given that a lot of American people lived right on the edges of the wetland, they might not have wanted to elevate the water too much, so they may not have wanted to back up the water too much. So, but I definitely don't have much knowledge of that.
Okay. All right. Let's see. This is a question that's asked in a couple different ways. So hang on. Is tide range key in that by having such a big range in the same 12-hour tidal cycle found worldwide also mean that percent exceedance at the top is pretty brief because the rate of change needs to be faster to fit in such in such a bit range into the same tidal period.
Mhm.
And then the short inundation period allows Sitka spruce and other tidal swamp species to tolerate extended and frequent tidal inundation of their root system. Maybe also a factor in spruce's root disc instead of root ball. So do you get the gist of the question, or shall I read?
I do, and I have my Q&A open so I can read it too. And
Oh,
Matt,
super. Okay.
yeah, Matt, thank you. I knew you would have, I mean, I didn't know you would be here, but if I had known you were going to be here, I would know you would have an excellent question. So, you know, really, although some exceedance value is a very interesting metric as they've been calculating it in the Columbia, that means how long things are inundated and how deep they're inundated. Really, from a wetland perspective, all that matters is soil saturation. So if the water only was above the soil surface for 5 minutes, you know, it's, well, maybe 10 minutes or 20 minutes, it's going to saturate that soil profile. We don't have a phenomenon of only surface saturation. They call it episaturation. We don't really see that. So I think, I don't think that the brief saturation or the brief inundation has super different biological effects from inundation that might have lasted a little longer. So it's kind of a hard question to answer briefly, but the swamps, when I've spent time in them, they are just super wet. So even though they're fairly high in that tide range, and even though the tide does go up and down a lot, and so it's only at the surface briefly, they're super wet. So they're not exactly on the margins of being a wetland. They are super wet.
Okay. So what is the effect on coastal waters and marsh tidal swamps of feedlot spraying on fields?
So referring, I assume, to manure spreading. I'm going to assume that's
how
the case.
I would interpret it. Yeah.
Yeah. Well, it's nutrient loading, and so as those nutrients make their way through the system, if they move into undiked wetland, they can be processed by the plants in the wetland. If they are just going straight out into the bay, they could have some bad impacts on, say, oyster production or something like that, where you might have some bacteria that you don't want. So I would say it's a nutrient loading issue, and wetland functions. One of the wetland functions that's really valued is the nutrient processing capability of wetlands. So that's a good question.
Mm-hmm. Okay, Melissa wants to know, how is historic forest cover determined, and in what time period?
Yeah, Melissa, the data we use for the historic vegetation mapping are from the 1800s. They were made from two types of maps: the General Land Office surveys, which were, I believe, a branch of, I can't remember exactly, the Coast Survey. And they looked at vegetation mainly because it provided some indication of agricultural potential and other land use capabilities. So they marked tree species and sometimes referred to size, and they took records on the mix of vegetation at what witness posts and section quarters and things like that. And that's where that information comes from. Some of it also comes from Coast Survey charts, which mapped areas of forest and shrub and marsh on the coast. Those were part of navigational mapping for our coastlines.
So Ken would like to know, is the root platform formed on nurse logs?
Sometimes those spruce are growing on nurse logs, but when I've seen the platforms tipped up there, I don't see like a big root underneath the flat part. So, I mean, I don't see a big log underneath the disc. So I think probably not always, probably sometimes.
Okay. Casey would like to know if you know why tidal marshes have increased in areas where they didn't exist historically.
Yeah, Casey, I think it's a mix of, on our coast in Oregon and in the Northwest in general, we have a pretty high sediment supply. It's a steep gradient coastal watershed. So sediment comes barreling down naturally through our river systems, and then it spreads out. The sediment and the water spread out in the bay. We have these drowned river mouth estuaries, and as the water slows, that sediment is deposited. It doesn't all go out to the ocean, although actually a vast majority of it does go out to the ocean. But enough of it is deposited as the water slows that you will build up the mud flat in the bay. You'll build it up gradually, and eventually it builds up to where plants can live on it and it becomes tidal marsh.
Okay. All right. So we have another question from Ken. The Swampland Acts of the 1870s likely led to much of the change in ownership and diking, along with the flood control acts of the 1930s and 1940s. Actually, I guess that's a comment.
It's a comment. Yeah, thank you, Ken. I don't know a lot about the history of the land use actions, but I know that I've certainly heard a lot about the Swampland Acts. Yeah.
Okay. All right. So I'm just going to remind people at this point that we're approaching the end of the questions that are in the Q&A box. So if you are thinking about asking a question, please get them entered right away. So Kathy says she lives in a tidal swamp area that is ready to be restored. What or how is the best way to move forward?
Oh, that's exciting to hear. Wow. Most of the time when I've worked on restoration projects, it's been with the watershed councils. They are wonderful organizations that pull together technical experts and people with all kinds of background, and they all have an interest in improving conditions in the watershed. And so I would say get in touch with your local watershed council and let them know that you're interested in doing this, and then they can help organize a technical advisory group, because most projects need a few experts to advise on how to do it.
Okay. All right. So Ray would like to know, what is considered an ideal tidal swamp?
What an interesting question. But that's like asking me what my favorite plant is. I don't really have one. There's a range of tidal swamps that are each interesting and valuable. So I think what we hope for, the ideal situation, is that we have an array of types of swamps that at least replicate some of the elements of what was present historically. I guess I would say an ideal tidal swamp is one that has the functions that were present in a tidal swamp that we care about and that will be resilient into the future.
Okay. So Greta comes back to ask, are the log cribs eventually deconstructed, or does the spruce bust it apart as it grows?
I'll bet. They're new still, but I'll bet the spruce will definitely break it apart as it grows, given how spruce growing on a nurse log will ultimately, their roots will sort of break that nurse log up.
Okay. Jean asks, almost any bayside project in Tillamook County seems to run afoul of no net rise rules from FEMA. Do you have any experience with this?
Yeah, FEMA was a major funder for the Southern Flow Corridor restoration actions, and it did involve some setback dike construction. So I guess it's possible to work within those rules. Most of our work doesn't involve placing new fill in the floodplain, so it usually more involves removing fill. But I think it's going to be an individual case-by-case, working with the regulators kind of thing.
Okay, let's see. I have a question over here in the chat box that snuck in. So it says, Laura, could you briefly describe the impact of the 2007 storm and spruce loss to Coal Creek Swamp?
It changed the structure, certainly. We had a bunch of big trees go down, probably primarily on the edges where they're more vulnerable. But trees naturally go down in these swamps, and then the openings are filled in with a diversity of brackish-tolerant shrubs, and that shrub habitat is very valuable wildlife habitat too. So I think it's a natural process, and the swamp goes on.
Okay. So Curtis says, wow, fantastic, Laura. Thanks for your talk. For those practitioners out there, what is one thing you see restoration folks doing that they should be doing better, or what are opportunities that are commonly missed?
Well, I guess you'll allow me to get on my hobby horse of monitoring. I think it may be that we could do a better job of monitoring at some projects where not a lot of monitoring is done, and funders are reluctant to fund a lot of monitoring, and yet we have so much we need to learn. So there are always design issues, like some projects don't use good reference for their design decisions. Some don't have a restoration design team that's multidisciplinary. So I guess there's a number of things that often could be done a little better maybe, but I'm just excited that so many restoration projects are happening and that we've had an opportunity to do the monitoring that we've done that has told us what we've learned. Thank you, Curtis, for the compliment.
So Bobby asks, what is one thing you wish more people understood about forested tidal wetlands that was not in your initial remarks?
I would say the thing people don't get about them is that they're very beautiful. They're very aesthetically satisfying. And I think the reason it's hard to know that is because it's really hard to get into them and be in them. But the richness of that wet habitat and having it be a forest too is quite exciting and aesthetically appealing. They're gorgeous. They're magnificent.
Okay, let's see. I think I have one last question, and then I'm going to read you some feedback that has come in I'd like you to hear. Are there tidal swamps that you have wanted to explore that you have been unable to do so?
Oh, yeah. I wanted to walk in every single tidal swamp on the coast. But so far I have not been able to walk in them all. So yes, I always dream of getting into, there's places out in the Columbia I would love to go, but it's always time consuming and logistically challenging. And for some reason I end up in front of the computer a lot. So, yep.
Okay, well, Doug wants to thank you for the comprehensive presentation. Nice to see over 20 years of personal observations find credence through your science-based studies.
Thank you, Doug.
And Matt thanks you. Good point that the groundwater saturation introduces a different time scale in addition to the tides. Mm-hmm. And Ken also thanks you for helping raise awareness of these important coastal ecosystems. And Alex thanks you also. So I think what I'm going to do is ask the other two panelists, Ben and Caleb, to come to join you on the screen right now. I didn't really pick a question out that they may want to respond to, but if they have reason to want to say something, why don't we give them a chance to do that?
Sounds good.
Okay.
Great. Laura, this is Ben.
Hi.
I guess I should turn on my video. I got a couple questions. I'll try one and then hopefully Caleb will jump in. One of the questions I have on restoration, the picture behind me in my image is Bott's Marsh, and we have a lot of stranded wood up there. And a lot of that area doesn't have Sitka established in it yet. Do you know of folks who have gone into areas of large stranded wood and actually, cut open logs and planted Sitka on stranded wood like that? Is that approach that you're aware of?
I have not seen that used yet. I think one of the challenges might just be that the areas that strand wood like that are bound to be quite dynamic in a storm, and you might get some destabilization of your plantings or losses of your plantings because of new wood piling on and the wood moving around during high tide events. So nature is doing what nature will do, and it might just be a little challenging environment to work in. But if there's a place behind the wood pileup that is sort of protected by it and is a little higher up, that might be a little easier place to work.
Caleb, you got anything, or should I keep going?
You can keep going if you want, Ben. That's fine.
Okay. Laura, I'd like you to talk a little bit more about the use of the habitat at high tide outside of the established channels by salmonids and other fish. I
lost your sound, Ben.
I'm sorry? Can you hear me?
Now I can hear you. You left off at, you'd like to talk more about the use of the habitat.
Yeah, outside of the channels at high tide. I've never noticed much stranding either in the pools or anything. Do the larger fish go out there into the sort of grassy areas, and can you talk about that a little more? I
would say the fish using these sites are usually young ones, and so you might not see them. But also they're really, really good at not getting stranded. I remember one project I was hearing about where they were concerned because there were some pools that were being formed by construction activities, and a fish biologist who'd studied fish behavior pointed out that the fish are very good at detecting when the water levels are dropping and making their way out before it's too late. So yeah, they do get out on these surfaces, and there's so much to eat. I mean, if you've ever watched when the tide first comes up into a channel that's been fully drained, you can see all these insects crawling out because it's getting really wet, and that's, I'm sure the fish are just loving that.
Yeah. Another question, if in looking for places to restore Sitka swamp, we're obviously going to be looking at tidal marsh areas. Can you talk a little bit about the trade-offs, the value of both habitats, and if one establishes Sitkas in an area, what the trade-offs are with respect to the tidal marsh?
Well, you know, they each have their place, and if your conditions, your physical conditions are right for tidal marsh, then restore tidal marsh. But if your physical conditions are appropriate for tidal swamp, then I would say give it a go. And they each have benefits. There's a lot of turnover, food web support through a low marsh, like a Lingby sedge marsh. It produces lots of organic matter that enters the food web. So that marsh is a lovely thing, but the tidal swamp is rare, and we need to bring back more of it. So I would say just look at your site and figure out which parts of it are more appropriate for marsh versus swamp, and then divide your work up accordingly. You know, don't try to make swamp where it should be marsh, and vice versa.
Yeah. Last comment I want to make is I love hearing somebody talk about shifting baseline syndrome. I've heard about it in fisheries quite a bit. And in, for example, coral reefs and such, where we think the current conditions are beautiful, but that's because we don't know what they looked like 3, 4, 5, 6 generations ago. So I appreciate you mentioning that. Caleb, anything else you want to add?
Yeah, I want to jump in with one quick question.
Great.
You showed a lot of really cool pictures at super beautiful swamps and forests. Is there a good public place people could go and look at a spot like this? Someplace you would recommend that has a public access point, especially in our general region?
Yeah, you know, I think the easiest place to see a tidal swamp somewhat comfortably is to take a kayak out on Hoquarton Slough in the Tillamook, because there's a boat ramp right near the Highway 101 bridge across Hoquarton Slough. You know, it's the first bridge as you head north out of town, but if you go a little to the west, on the south bank, there's a little place where you could walk your kayak down into the water. And Hoquarton Slough is one of the larger remaining tidal swamps on the Oregon coast. So, and it's Sitka spruce dominated, so you could get a very good sense of what that's like by kayaking through there.
Good
Great.
point, Caleb.
Great.
Nothing.
Well, my other comment would just be thank you so much. That was a great presentation. Enjoyed it.
Thank you. Thank you for organizing this, Caleb and Ben and everybody else, including you, Debbie, and all the others behind the scenes. This was like the best organized web talk I've given. Thank you.
All right, with that, we're going to draw this to an end. I want to thank Laura, Caleb, and all the attendees, wherever you are. Sounds like we had a pretty good geographic spread. And thank you to the Lower Nehalem Community Trust, the Nestucca, Nestucca, and Sand Lakes Watershed Council, and the Estuary Technical Group at the Institute for Applied Ecology. I encourage everybody to visit those websites. Tomorrow, we are going to be sending out a follow-up email. So if you have any other further questions, please feel free to respond to that email with your questions, and we'll get them answered as soon as possible. The email will also contain a link to the video recording from tonight's presentation. Also, remember, our next webinar will be on March 29th. We haven't set a time yet because we're dealing with people from the East Coast and Colorado, and so it's a little bit tough. We haven't set that yet. Please watch for announcements later.